In this video, we're going to talk about how to determine whether a point is on a line. So in algebra, we use the coordinate plane to show the relationship between two variables. There are two axes on the coordinate plane. The horizontal axis is called the x-axis. The vertical axis is called the y-axis. These two axes divide the coordinate plane into four quadrants that are labeled here. So points on the coordinate plane are located by ordered pairs. In an ordered pair, the first number is the x-coordinate and the second number is the y-coordinate. So this graph shows you the point that is represented by the ordered pair 3, 2. 3 is the x-coordinate and 2 is the y-coordinate. A linear equation is an equation that represents the graph of a line. Y equals negative x plus 6 is an example of a linear equation. You can see from its graph that the graph is a line. Every point on the line is a solution to the equation. An ordered pair, xy, is a solution to the linear equation if the equation is true when the x and y values are plugged into the equation. So let's look at the graph of y equals negative x plus 6. There are in fact an infinite number of points on this line, but we can find a few examples. So you can see here it includes the point 0, 6, the point 3, 3, the point 6, 0, the point 8, negative 2. So I've given you a few examples of points that are on this line, but there are in fact an infinite number of points on this line. As you can see by the arrows at the two endpoints of this line, this graph will extend beyond what's shown here on this coordinate plane, and it will in fact go on forever. So let's determine whether the point 0, 6 is on the line y equals negative x plus 6. So in this case, we're given the graph of the line, so you can go to the graph and find 0, 6, and you can see that this point is in fact on the line. But I'm going to show you how to verify this algebraically. Remember that 0, 6 tells you an x value and a y value. So to check whether this makes the equation true, we're going to plug in this x and y value into this equation given here. So we're going to check whether 6 equals negative 0 plus 6. So 6 equals 0 plus 6, which tells us that 6 equals 6, which is true. So that means that 0, 6 is on the line. So let's determine whether the point 4, 2 is on the line, y equals negative x plus 6. So once again, we have the equation, so we can go to the graph and look and see 4, 2 is in fact on our line. But let's verify this algebraically. So 4, 2 is my x and my y value. So I'm going to plug into this equation and check whether 2 equals negative 4 plus 6. So this is telling me that 2 equals negative 4 plus 6, which is 2, and that is true. So that means that 4, 2 is on the line. Because remember that a point that is on the line will make the equation true when you plug it into the x and y values. So now let's determine whether the point 3, negative 1 is on the line. So let's find the point 3, negative 1, and you can see that it's out here, so it should not be on our line. Let's verify this algebraically. So I'm going to label this point xy. When I plug it in, I get negative 1 equals negative 3 plus 6. So this is telling me that negative 1 equals negative 3 plus 6, which is 3, which is not true. So 3, negative 1 is not on the line, which we already found by looking at the graph. Now let's determine whether the point negative 4, negative 17 is on the line 3x minus y equals 5. So remember, we're going to start off by labeling this point, because although we're not given the graph, we can actually plug in and determine whether this point makes the equation true. So when I plug in for x, I get 3 times negative 4 minus y, which is negative 17. Remember to be careful and keep up with those subtraction and negative signs. And we're checking if that equals 5. 3 times negative 4 is negative 12. And then I have minus negative 17, but remember that a minus negative will turn into a plus. So I'm checking whether negative 12 plus 17 equals 5. Negative 12 plus 17 does equal 5, so I get a true statement. So that means that -4, -17 is on the line. So an ordered pair xy is a solution to a linear equation if it makes the equation true. If an ordered pair is a solution to a linear equation, then it is included in the graph of the line.